sources. Let's add the exam checklist, an exam checklist here. I think it's that, yeah. Okay. We gotta get 90% on all lesson quizzes. Plus, oops, let me spell that right. How do you spell quizzes? Like that. 90% plus. I'm just gonna be quick with it. Less verbose, 90% plus. Lesson quizzes, 90% plus. PBQs, 90% plus. Practice questions, 90% plus. Hold on, let's see. What is this? Yeah, we're kind of screwed with this. Let's do that. Go back here. We're done with this. We can go here. We should be here. Yeah. Okay. Complete all lessons and activities. And all labs. 2 practice exams are available. Multiple attempts on both are allowed. First practice exam. Oh, I should do this first. And then do this. If I did 90% or better, then continue. If you scored less, put together a plan to strengthen skills and topics needed. Labs from InfoSec learning. What even is that? I get access to this? What is chatter? Nah. This one. Jason Dion, textbooks. Okay, whatever. And then you do cert master practice. So lesson Qs and PBQs. Cert master practice questions. Morning, bro. Let's see, lesson quizzes, PBQs, and then after that, cert master assessment, and then here, cert master practice test, cert master assessment, practice questions, and practice test. Okay. Continue to the first attempt checklist. This thing? So let's do this, okay. Lessons, PBQs, practice questions. I should have renamed that. 90%. Lesson practice questions. PCs, installing motherboard connector. I'm gonna read through my notes real quick. Okay, components of a personal computer. There's the chassis and tower, and peripheral devices, cables. Chassis and tower, system case / chassis / tower. Yeah, temperature display, air vents, okay. Side cover that can be removed by sliding the panel from its housing. Front panel has LEDs, indicate drive operation. Rear panel has the PSU sockets. PSU is integral fan exhaust. Below the PU is the motherboard input/output ports. Allow for connection to peripheral devices. Bottom of the case, make sure additional extra expansion card, I/O ports, slots, blanking plates, cover it if not used. Don't let dust get in, dust will cause overheating, ESD. Okay. Peripheral devices. Anything important to know here? HDMI, DVI, SATA, USB, RJ45 audio ports, interfaces. Hardware port is the external connection point for a particular type of bus interface. Bus allows the transfer of data. Most connectors and ports have asymmetrical, use edge contacts with an asymmetric design called keying to prevent them from being inserted the wrong way around. Binary data storage and transfer units. It's appropriate to use the right units. Computers process binary data. Each binary digit or bit, lowercase b, can have the value 1 or 0. Storage is often in multiples of 8 bits, referred to as a byte, which is capital B. Lowercase b is bit, uppercase means byte. I don't need this. Yeah, I don't need that, that's redundant. Transfer rates are expressed in units per second of the following multiples of bits and bytes. 1000 kilobits and kilobytes. 1,000 kilobits is different than 1,000 kilobytes. So what is it trans? Kilobits or 1,000 kilobytes. 1,000 by 1,000. That's okay. So 1,000 bits is a kilobit, and 1,000 bytes is that's what it's saying. 1,000 is kilobits. 1,000 is kilobytes. 1,000 by 1,000 is megabits or megabytes. Which okay. And 1,000 times 1,000 times 1,000 is a gigabit or gigabyte. Cable types and connectors, USB cables. Universal serial bus is a standard means of connecting most types of peripheral devices to a computer. USB peripheral device functions are divided into classes. USB is managed by a host controller. Okay, each host controller supports multiple ports attached to the same bus. Could be up to 127 connected devices per controller. Dang. But to overcome the limitations of sharing bandwidth, most PC motherboards provision multiple USB controllers, each which has 3 or 4 ports. USB standards. There have been several iterations of the USB standard. Each version introduces better data rates. USB 2.0 specifies a data rate of 480 megabytes per second, or megabits per second, shared between all devices attached to the same host controller. The bus is half duplex, meaning each device can send or receive, but not at the same time. And then USB 3.x standard introduced a new connector form factor. Did it really? And upgraded, maybe same kind of port, but a little bit different on the, no, because USB 3 and 2 works in the same slots. I don't know. Okay. New connector form factors and upgraded transfer rates. Each are fully duplex, so a device can send and receive simultaneously. Okay, so USB 3 is full duplex, USB 2 half duplex. 2 half. 3 full duplex. USB 3.2 deprecated some of the older terms used to describe the supported transfer rate. Standard. USB 3.2 Gen 1 super speed USB is 5 gigabits per second. Legacy designation 3.0. So now it's 3.2 Gen 1. And then there's 3.2 Gen 2 by 1. Wait, do I need this? Is that the name of the standard? Lesson 1. Cable types and connectors. Yeah, it is. Okay. So 3.2 uses USB-A, USB-B, USB-C, USB micro. 3.2 super speed 10 gigabit is USB-A, USB-C, USB micro, and USB 3.2 Gen 2 by 2 super speed USB 20 gigabits per second, 10 by, okay, and that's USB-C. Legacy designation none. USB 3 controllers feature 2 sub-controllers. Here, this can be way better organized. USB 3 features 2 sub-controllers. One controller handles super speed devices, or super speed capable devices. The other supports legacy high speed. Consequently, legacy devices will not slow down super speed capable devices. One controller handles super speed capable devices. The other supports high speed, full speed, and low speed USB version 1.1 and version 2.0 devices. Consequently, legacy devices will not slow down super speed capable devices. Okay. 2 subcontrollers. Okay, I see. USB connector types. Type A for connection to the host and some types of peripheral devices. Should I do it like that? For connection to the host and some type of peripheral devices, connector port are shaped like flat rectangles. Connector and port are shaped like flat rectangles. Connector should be inserted with the USB symbol facing up. Yeah, I like that a little better. For connection to large devices such as printers. The connector and port are square with a beveled top. Type B. Type A. Type B. Type B mini. Type B micro. Type B mini, a smaller peripheral device connector. This type of connector was seen on early digital cameras but is no longer widely used. Type B micro, an updated connector for smaller devices such as smartphones and tablets. Distinctively flatter than the older mini type of connector. Type B mini, type B micro, type B. USB cable can feature type A to type A connectors or can convert from one type to another, type A to type B or type A to type B. Wait, type A to type B or type A to micro type B. Micro type B. It should be type B micro. To type B micro, for instance. USB 3. There are new versions of the Type A, Type B, and Type B micro connectors with additional signaling pins and wires. USB 3 receptacles and connectors often have a blue connector tab or housing to distinguish them. USB 3 Type A connectors are physically compatible with USB 1.1 and 2.0 connections. Okay, so physically compatible. But Type B micro connections are not. Example, could plug a USB 2 Type A cable into a USB 3 Type A port, but you cannot plug a USB 3 Type B cable into a USB. Oh, so this should be indented and indented. Okay, USB connections are not. USB 3.1 defines the USB-C connector type, intended to provide a single consistent hardware interface. For the standard, connector is reversible, more robust than mini B and micro B types. SBC can use the same type of connector at both ends, or you can obtain a USB. It should be this. USB-C can use the same type of connector at both ends, or you can use USB-C to USB-A. Okay. Cable length. Maximum cable length for low-speed devices is 3 meters. For full speed and high speed, the limit is 5 meters. Maximum cable length. Let me do this. Low speed devices is 3 meters. full speed and high speed. Is 5 meters. Do not have an official max length. Let's do that, take that out, go down here, place it on a new line, do like that, like that. Let's do super speed cables. About 3 meters. Okay, and this goes down here. Nice. Way better. Okay, low speed devices, 3 meters, full speed and high speed, and super speed. So 3.0 is super speed, right? Super speed, super speed, super speed. 2.0 is high speed. So I'm assuming USB 1 is low speed. Full speed and high speed is version 2. Just want to confirm USB version 1. Is USB version 1 called low speed? Oh, it has low speed and full speed. Okay, so there's different speeds, so it's not going to be just by the version 1 can have low speed and full speed. And then it's just a new version of that. Okay, makes sense. So low speed 3 meters, full speed, high speed 5 meters, super speed 3 meters is recommended. Okay. Let me see the steps here. I'm on this, okay. Cable length, okay, power. As well as data signal, the bus can supply power to connected device. Most USB A and C ports can be used to charge the battery in a connected device. Basic USB ports can supply up to 4.5 watts depending on the version. It should be all bulleted. Bulleted is way better for notes for reading through this stuff. Basic USB port can supply up to 4.5 watts. Power delivery capable, PD capable port can supply up to 100 watts given suitable connectors and cabling. Cool. Cool. Nice. Dang, there's a lot here. HDMI and DisplayPort video cables. We'll probably have to start skimming this a little bit faster. USB interface supports many types of devices, but not for video. Video has high bandwidth, so they need a dedicated interface. Okay. Video cable bandwidth is determined by 2 factors: the resolution of the image and the speed at which the image is drawn. Should I do this? Like that. Resolution of the image. Speed at which the image is redrawn. Why does this change, bro? Oh, cause this. Yeah, okay, I see. The speed at which the image is redrawn. Resolution and speed. Which is, yeah, resolution and then hertz. Or FPS. Frames per second for video. Or hertz for display. Uncompressed HD video at 60 FPS requires 4.5 gigabits per second. 4K at 60 FPS requires 8.91 gigabits per second. Oh, okay, this is important. This describes this. Note. Oh, I didn't even notice I put note there. That's crazy. I never did that before. Okay, we can reorder this. Frame rate in FPS is used to describe the video source. That should be one bullet. Hertz is the refresh rate of the display device and video interface. To avoid display artifacts such as ghosting and tearing, the refresh rate should match the frame rate or be evenly divisible by it. E.g., if the frame rate is 60 FPS and the refresh rate is 120 Hz, the video should play smoothly. Maybe not. Nope. Maybe I want to call it, good morning. I'm gonna do a custom name actually. Let's do FPS versus Hertz. Yeah. One more day, good luck. Good luck, study hard. How you feeling? Info. Frame rate in FPS is used to describe the video source. Hertz is the refresh rate of the source and the maybe I should do speed. FPS versus Hertz. Frame rate is in FPS is used to describe the video source. Hertz is the refresh rate of the display and video interface. So to avoid artifacts such as ghosting and tearing, refresh rate should match the frame rate or be evenly divisible by it. That's pretty good. Pretty good. Computer displays are typically LCD, TFT type. Each pixel in LCD comprises cells with filters to generate 3 additive colors. Each pixel is addressed by a transistor. Panels illuminated by LED or array or backlight. Here, okay, let's see. LCD TFT is often just referred to as flat panel display. also called LED display after the backlight technology. Oops. Premium flat panel monitors are of the OLED type. Each pixel is its own light source. Better contrast and color fidelity. HDMI video interface, most widely used one. Supports video and audio, remote control, and digital content protection (HDCP). Supports for high-res 4K, 8K gaming features such as varying the monitor refresh rate to match the frame rate of the video source. Ah, okay. That's going to reduce up here. Ghosting and tearing. Okay, so that's why the variable frame rate, all that, what is it called? AMD, like VSync or something? Is that what that is? VSync? Video sync, VSync, AMD VSync. Vertical sync is a frame rate synchronization method designed to eliminate screen tearing and stuttering. Yeah. So that's the AMD's version. So where was that? Here. Varying the monitor refresh rate to match the frame rate. Okay, so the monitor syncs to the frame rate. Syncs the refresh rate to their frame rate. Support for audio is useful because TVs and monitors have built-in speakers. Oh, this should be bullet points to be easier to read through, skim through. Support for audio is useful because most TVs have built-in speakers. Video card must have an audio chipset for this to work. Full-size Type A, Mini Type C, and Micro Type D connectors, all of which are beveled to ensure correct orientation. So there's HDMI full-size, HDMI Mini, and HDMI Micro. Never seen the different ones like that before. Mini HDMI. Is that like the regular one? Probably. Mini, Micro, full-size. Okay, within there's two categories, standard and high speed. Supports greater lengths than is required for version 1.4 features, 4K and 60 Hz. HDMI versions 2.0 and 2.1 specify premium high speed up to 18 gigabits and ultra high speed up to 48 gigabits cable ratings. Display interface. So HDMI was developed by consumer electronics companies and requires a royalty to use. So then DisplayPort was developed as a royalty-free standard by VESA. DisplayPort supports similar features to HDMI such as 4K audio and content protection. There are full-size DisplayPort ++ and mini DisplayPort /MDP port and connector types, which are keyed against incorrect orientation. Bandwidth can be allocated along in bonded lanes up to 4. The bitrate of each lane was originally 2.7 gigabits per second, but is now up to 20 gigabits per second. One of the main advantages of DisplayPort over HDMI is support for daisy chaining multiple monitors to the same. Okay, so DisplayPort supports daisy chaining, HDMI does not. Using multiple monitors with HDMI requires one video card port for each monitor. What does that mean? I didn't elaborate that. Let's see. HDMI requires one video card port for each monitor. So each monitor has to plug into a video card port. That's basically what it means. Okay. That's DisplayPort. HDMI. Mini HDMI, mini HDMI. Thunderbolt and Lightning. Thunderbolt can be used as a display interface like DisplayPort or HDMI, and as a general peripheral interface like USB. So Thunderbolt's like the best. but Thunderbolt uses DisplayPort. It uses an adaptation of DisplayPort. Can be used as display interfaces like this. So DisplayPort can be used as this display interface because it uses what is it called? DisplayPort Thunderbolt adapter. What is it called? DisplayPort. I was learning about this. Maybe I don't. Not. Thunderbolt uses DisplayPort what? DisplayPort something. I'm just gonna type in Thunderbolt 4 or something like that and go to Intel, and it should say here. Maybe it's not gonna say. Oh, let me check, maybe here I have it, display tech differences. Yeah, it's here somewhere. DisplayPort alternate mode, yep. Yeah, so Thunderbolt uses the DisplayPort standard, but not really the DisplayPort standard, an adapted version of the DisplayPort standard that works for USB-C, which is called DisplayPort alternate mode. But that's getting into the details that we're not jumping into on this, I don't think. So, okay. So Thunderbolt version 1 and 2 use the same as mini DisplayPort. Ah, okay, so I know what that looks like, the old one. Yeah, DisplayPort 2. That's on my iMac, old school iMac. Well, I don't know, it depends what you call old school, but older iMac 2012 now. Thunderbolt version 3 changes it to be USB-C. USB device plugged into a Thunderbolt 3 port will function normally. Thunderbolt devices will not work if connected to a USB port that is not Thunderbolt enabled. Again, this should be... Not all USB-C ports support Thunderbolt 3. Look for the flash icon. USB 4 and Thunderbolt 4 standards have been developed. Converged standards and products are starting to appear on the market. Okay, Thunderbolt Lightning. It's for Apple. SATA hard drive cables. SATA hard drive cables, okay, as well as external cabling for peripheral devices. Some types of internal components use cabling to attach to the motherboard. SATA is means of connecting internal storage drives. Okay, so SATA is only for storage drives. Remember that. That's for storage drives. SATA uses cables up to for internal storage drives. Okay, terminated with compact 7-pin connectors. Cables up to 1 meter. Okay, 7-pin connectors. Each SATA host adapter supports a single device. 7-pin data pin does not supply power. A separate 15-pin SATA power connector is used to connect the device to the PC's power supply. Well, this is 1, 2, 3, 4, 5. Oh, pins. Okay. 7 pins. This colored one. Okay. 7 pins. Data. Big boy. Power. Front view of 6 SATA ports for data. And then there's Molex power connectors. Internal storage device data cables are unpowered, while the SATA power connector is the best option for new devices. Legacy components connect to the power supply unit via a Molex connector. Okay, so see, and this is the reason why I like taking the notes and organizing it in a way, because I'm able to create a conceptual map of all the information rather than just like a huge text of stuff. I have everything like organized to like as steps, like bullets, indentation of this, and it's easier for me to map through, kind of like a binary tree mapping. But so it's like video cables, and then indented here, storage cables, indented this kind, SATA within, internal storage devices have, data connectors that use SATA interface, but that doesn't power it, so there's 2 types of power kinds, OG Molex, newer ones that are power SATA or mSATA. Is that what that's called, mSATA? Power cable? Now, what's mSATA stand for? While SATA power connector is the best option for new devices, Molex connector. Molex connector is usually white or clear plastic and has 4 pins. Okay, so it's got 4 pins, Molex. Old school boy Molex. Oh, I have to memorize this. 4 pins. Red, 5 DC volts. Yellow, 12 DC volts. Black, ground. External SATA. eSATA. What's mSATA and uSATA? I remember seeing that. eSATA is external SATA for the attachment of peripheral devices. It uses an eSATA cable to connect to an eSATA port. Cannot use internal SATA cable. eSATA P is a non-standard powered port used by some vendors that is compatible with both USB and SATA. With eSATA P cable. USB interface dominates the external drive market, however. Okay. Here there's more, okay. Motherboard for devices that implement the core system functions of compute, storage, and networking. Motherboard functions is the aka the processor does the compute function. It's limited to a number of instructions internally at one time. Additional storage for running programs and open data files is provided through system memory, aka RAM, which is called random access memory. Storage technology is non-persistent. That should be this, that should be like that. Mass storage devices are used to preserve data when the computer is off. This should be, yeah. Software runs by running instructions in the CPU. Yeah, better information flow there. Okay. Where's cache? Cache. Processing and storage components are connected by bus interfaces implemented on the motherboard. Instructions and data are stored using transistors and capacitors, which are transmitted between components over the bus using electric signals, data, and instructions. Okay. The system clock synchronizes all parts of the PC, provides the basing timing signal for the CPU. Clock speeds are measured in megahertz or gigahertz. That should be indented. They should be indented. Clock multipliers take timing signal produced by the generator and apply a multiplication factor to produce different timing signals for different type of buses. One type of bus can work at a different speed to another type of bus. Type of motherboard influences system speed and the range of system devices and adapter cards that can be used or upgraded. Each motherboard is designed to support a particular range of CPUs. PC CPUs are typically manufactured by Intel and AMD. So there should be something about cache here. Motherboard functions. Maybe not. What else is there? ESD. Connectors, system memory connectors, motherboard connectors. CPU sockets. CPU socket has the square shape. It's covered by thermal paste, heat sink, and a fan. Function of the CPU is supported by the motherboard's chipset. It consists of controllers that handle the transfer of data between the CPU and various devices. Okay. Chipset is soldered onto the motherboard and cannot be upgraded. Type of chipset on the motherboard determines the choice of processor. Type and maximum amount of RAM. Support for integrated interfaces and ports. Radio, sound, networking, etc. Can't be interfaces that are not supported can be installed or upgraded as an adapter card. Okay. Memory slots. Okay, packages. This should be like highlighted. Normally packaged as dual inline memory module, DIMM, fitted to a motherboard. The DIMM slot has catches at either end, located close to the CPU socket, is numbered and often color-coded. There are successive generations of RAM technology. A DIMM form factor is specific to a particular DDR version. A label next to these slots should identify the DIMMs supported. Motherboard storage connectors. Use either SSD or HDD. SATA for fixed drives. Can also be used to connect removable drives. Okay. Tape drives and optical drives. SATA devices are installed to a drive bay in the chassis. Connect to a data port via cable. Enter the power supplies via a SATA power or Molex. Okay. Yeah. M.2 interface is the interface for SSDs. Oriented horizontally. Adapter card is inserted at an angle and pushed into place and secured with a screw. M.2 adapters can be different lengths. Okay. M.2 supplies power over the bus, so there's no need for separate. Okay. eSATA again. There's also an eSATA cable standard for attachment of external drives. Must use an eSATA cable. eSATA P is a non-standard. Bro, I feel like I wrote this same exact thing under here. Basically. Okay, motherboard storage. Main drawback of eSATA compared to USB or Thunderbolt external drives is that power is not supplied over the cable. Not so much of an issue for 3.5 inch drives, which require a separate power supply. But limits the usefulness of eSATA for 2.5 inch portable drives. Yeah, that's better. Cool. What else we got going on? Motherboard adapter connectors. Expansion slots accept plug-in adapter cards, okay. And for expansion cards they use, okay, PCIe or PCI. Should this be like that? Maybe, I don't know. Okay, so PCIe is the bus mainstream interface for modern adapter cards. Each point-to-point connection is referred to as a link. Uses point-to-point serial communications, meaning that each component can have a dedicated link to any other component. Each point-to-point connection is referred to as a link. The raw transfer rate of each lane depends on the PCI version supported. Transfer rates are measured in gigatransfers per second. Throughput in gigabytes per second is the rate achieved after loss through encoding is accounted for. Raw dogging it, no coffee, baby. Adapter slots with more lanes are physically longer. Okay. Each PCIe adapter card supports a specific number of lanes, typically 1x, 4x, 8x, or 16x. Ideally, a card should be plugged into a port that supports the same number of lanes. If insufficient slots are available, a card will fit in any port with equal or greater number of lanes, referred to as upplugging. Example, 8x card will fit in an 8x or 16x socket. Upplugging. Card should work at 8x, but in some circumstances may only work at 1x. It's possible to fit a longer card into a shorter slot, referred to as downplugging, as the card is not obstructed by other features in the case, or if the card is not, if or as the card. All PCIe versions are backwards compatible. Buslink works at the speed of the lowest version component. PCIe can supply up to 75 watts to a graphics card via a dedicated graphics adapter slot, and up to 25 watts over other slots. And extra 75 watt power can be supplied via PCIe power connector. Slot may support a lower number of lanes than its typical physical size suggests. Number of lanes supported by each slot is indicated by a label on the motherboard. E.g., slot that's physically x16 but supports only x8 operation will be labeled x16/x8 or x16 at 8x. Okay. PCIe or PCI. Computers often support more than one expansion bus, often support older technologies. PCI's legacy, PCIe, okay, so it probably has PCIe and a PCI. Superseded by PCI Express. PCIe is software compatible with PCI, meaning that PCI ports can be included on a PCIe motherboard to support legacy adapter cards, but PCI cards cannot be fitted into PCIe slots. PCI uses parallel communications. Most types of PCI are 32-bit and work at 33.3 megahertz. Transfer rates up to 133 megabytes per second. That is 32 bits divided by 8 to get 4 bytes. Then multiplied by the clock rate of 33. Oh, okay, yeah. So 32 bits divided by 8 per byte is 4 bytes times 33.3 megahertz is clock rate of 4 times 33 would be 133, I suppose. So 33 megabytes per second. Cool. Okay, easy stuff. Earliest PCI cards designed for 5 volt signaling, but there's 3.3 volts and dual voltage cards. But those ones became more prevalent. Okay. The keying for 3 types of cards are different. Motherboard form factors. There's the ATX is the standard form factor. Full size boards are 12 inches by 9.6 inches. And then there's micro ATX or MATX is okay, micro. 9.6 inches. Square board. 4 expansion slots, 7 expansion slots. And there's the ITX form factor, Information Technology Extended, Advanced Technology Extended, Information, okay. Small form factor PCs are popular, okay. They use mini ITX. Is 6.7 inches square. Okay, so small form factors are square. Micro ATX, mini ITX, 6.7. So the mini ITX smaller than micro ATX. 1 expansion slot. Oh, these are tiny. Small cases. But most mini ITX boards can be mounted in ATX cases. Okay. There are also smaller nano, pico, and mobile ITX form factors for embedded systems portables. Okay. So the smallest thing, ITX. Common ones, ATX with a micro version if you want that. Okay. Motherboard installation, there's standoffs, installation procedure, you just connect it, whatever. Headers and power connectors. In addition to slots and sockets for system devices, motherboards also include connectors for components such as case buttons, speakers, and fans. Yes, okay, so for the case stuff. And those are called, I suppose, the headers then. Front panel headers here, 9-pin USB headers, audio headers. Okay, so you gotta connect the USB slot ports to the motherboard with the headers here. The audio interface, you gotta connect that as well, and the front panel headers. The general front panel. Okay, cool. That makes sense. Components in the front and rear panel in the case are connected to headers on the motherboard. Okay, makes sense. Power button. Drive activity lights have to connect as well. Audio ports have to connect. USB ports have to connect. Connections are made to the 9-pin headers, which accept up to 2 4-pin port connections. The 9th pin is to orient the cable correctly. USB 3 headers are 2x10 format and can be cabled to 2 ports. Or 2x10 format, okay. When disassembling the system, you should make a diagram of the position and orientation of header connectors. If you do not have a diagram, you'll have to refer to the motherboard documentation or go by the labels printed on the wireless headers. Okay, power connectors. Motherboard also contains various connection points for the power supply and fans. The main P1 motherboard power connector is a distinctive 2-pin by 12-pin block with a square pin receptacles. Okay, so that big boy one is the power connector, the P1. The fan connectors, they should be as well. Or no, that should not be that. That should be this. Okay, so fan connectors are 3 or 4-pin Molex KK format. One for the CPU, one or more for the case fans and components such as memory and video adapters. 4-pin fans connectors support precise fan speed control via pulse width modulation (PWM) and signal carried by the blue wire. 3-pin fans are controlled by varying the voltage. Fans with a 3-pin connector can usually be used with 4-pin headers. But system may not be able to vary the fan speed. A fan with 4-pin connector will usually work with a 3-pin header, but will not be able to use PWM. Expansion cards. Okay, and these are just linked here. Expansion card adds functions to the ports that are not supported by the integrated features of the motherboard, and those fit to PCIe or PCI. So video cards. Basic test for GPUs, the frame rate it can produce for a particular game or application. Graphics memory. 3D cards need a substantial amount of memory for processing and texture effects. So maybe fitted with 32 gigabytes GDDR or graphics DDR RAM at the high end. 8 gigs would be gigabytes would be typical for current mid-range performance. Low-end cards use shared memory. Some cards may use a mix of dedicated and shared. Video ports, the type and number of connectors such as HDMI, DisplayPort, and Thunderbolt. Okay. So video cards have ports on. Wait, do they have ports? Ah, they do. I see. Graphics double data rate, GDDR memory technology is similar to the DDR modules used for system RAM. but I'm not expecting a but there. But I guess there was none. Okay, most cards use a PCIe X16 interface. Dual cards using 2 or more slots are also available. Dual cards, that's heavy performance. Okay. Capture cards. Where graphics cards generates an output video signal to a drive monitor, a capture card is used to record video input and save it as a type of movie or streaming media file. Sound cards. Playback is achieved via speakers or headphones connected to a sound card, via an audio jack. Most jacks are 3.5mm mono or stereo jacks, referred to as phone plugs or mini tip ring sleeve connectors. Tip ring sleeve connectors, phone plugs or TRS connectors. Mono and legacy systems, stereo and surround sound uses multiple speakers positioned around the listener to provide a cinematic audio experience. Basic sound chip may be provided as part of the motherboard, but better quality audio can be provided as a PCIe or PCI expansion card. Pro level cards may also feature onboard memory. There's a lot of good info for when I'm going to build a PC in the future sometime. Audio hardware built into a computer may be susceptible to noise from other internal components when using recording functionality. Audio hardware built into the computer may be susceptible to noise from the other internal components when using recording functionality. Consequently, most audio interfaces designed for professional use are external units connected via USB or Thunderbolt. Okay. Network interface card. Most computers have Ethernet network adapter already installed as part of the motherboard chipset. But may be occasions where you need to install an add-on NIC network interface card, or upgrade an adapter to use a different type of network or cabling connector. Dedicated NIC may also provision multiple ports, can be bonded into a single higher bandwidth link. Wi-Fi adapter can be added to connect to a wireless network developed to different 802.11 standards, or also cards that can connect to cellular data networks. Okay. And then legacy DVI and VGA. Yeah, this is like crazy, bro. Come on now. HDMI and DisplayPort interfaces only support digital flat panel displays. Older video interfaces were used when computer monitors and projectors were predominantly cathode ray tube type, driven by analog signal. So DVI, designed to support analog and digital outputs. No longer in active development. 5 types of DVI for single and dual link and analog/digital output signaling. Pin configuration of the connectors identifies what type of DVI is supported by a particular port. DVI A looks like this. DVI D single link. DVI I single link. DVI D dual link. DVI dual link. Okay, D is a single link like this. Dual link is the whole dotted thing. And then I is dash, or D is dash, I is this thing. D dash I this thing. And then DVI A is just the one that's different. DVI I supports both analog equipment and digital outputs. DVI A supports only analog. DVI D supports only digital. It's okay, so D for digital, I for both. A for analog, D for digital, I for both. Okay, that works. And then VGA is completely different. Okay, VGA is that 15 pin VGA was the port standard along video interface for PC devices for a very long time. Usually support full HD. Okay. What is it? Oh, I gotta know these two. Dang, there's a lot of ports, bro. Come on now. Let's see here, what is this at? Does this even support power, USB-C power? Yes, it does. Cool. How many volts is it though? That's the question. Let's really quickly figure this out. Digit here, products, docs, TS3 plus. Yeah, this guy, what is this one? Here. What do they mean data only? Up to 87 watts charging. Thunderbolt 3 downstream. Thunderbolt 3 host, Thunderbolt 3 downstream. USB-C data only. What do you mean data only? I'm charging right now. It says 5 volts. They just mean for the actual computer charging. Wait a minute. Audio in. Oh yeah, audio in should go there and out. What happens if I do this? If I do this. Yeah, that doesn't even work. Okay. makes sense. Whoa. Okay. I forgot to start that. There we go. Okay, anyway. Small computer system interface, SCSI. This should be like that. Background, modern bus interfaces such as USB Thunderbolt use serial communications. Serial links can achieve megabits and gigabits speeds through the use of improved signaling. Serial interface transfers 1 bit at a time. Parallel interface transfers 8 bits or more. Requires more wires and cabling and bulkier. So SCSI is one example of a legacy parallel bus. SCSI host bus adapter HBA can control multiple devices attached by internal ribbon cables or external SCSI cables. And it looks like this. A big boy. 32 megabytes per second. High density 68 pin or single is used with the Volex power, and then single connector attachment SCA 80 pin connectors, which incorporates power. Must be configured with the unique ID from 0 to 15. That's crazy, bro. DB9 pin connector and COM port. Serial port is referred to as a COM port. Nice. Okay, let's do what's in PBQ? PBQ for number 1. Oh, I already got 100%. I gotta call these out. Let's see if I can do 100% on this. Those are headers. 1. Input output connections? Yeah, input output connections. Headers. Two. Hold on, let me do 3. 3, that's the P1 power supply, main PSU power supply. 6. These are expansion slots. PCIe 16x slot. 7 is 1x slot. 8. CMOS battery. 6. Wait, what about 2, 4? 4 is the CPU socket. What is it? 2. RAM slot. And so 6 is did that. SATA port. Yeah, SATA with the L's. Easy. Now this one. Different power supply adapter types and their characteristics. This is Molex. Wait a minute. Uh-oh. This is Molex. What is this? Molex KK probably for mini. For the fans. Yeah, the fans for white. This is the P1. This is the big boy. This is a SATA power. But what voltage? Oh, and then this one. EPS? They didn't even talk about EPS. Or maybe they did. Oh, power supply connectors here. I didn't even read it, that's why. Black and yellow. Yellow is 5. No, yellow is 12. Red is 5. 3.3. Let's say this one's all? I don't know, bro. I don't know. Yellow is 12, red is 5, orange is 3.3. Yeah, so this one's not 3.3. This one has 3.3. This one has orange and yellow and red. This one's just yellow, which is 12. This one's yellow and red. I think that's what it is. How much you want to bet? If I get this, that's crazy. Because I have no idea. I knew it. Oh, I'm so good. I'm so good. I'm so good. Oh, dude. How could I pull from memory like a couple weeks ago? Bro, I just pulled that from memory. Just straight up. Straight up. That's called brute force memory, baby. I'm just built different. I'm built different. Built different. Telling y'all right now. Built different. EPS? What is even EPS for? I know this is for the fan. Hard drives can use Molex or SATA power. And then this is for the PSU. So what's this for? EPS. Did I even read that? Let's see. Nah. Motherboard header and power connectors. UPS, is it anywhere in here? This should be like that though. Fan connectors, 3 or 4 pin KK format. And I know that these ones are like white, I think. Easy. Built different, baby, built different. Manager directs a support technician to plug a device into the COM port. What port is the manager referring to? Serial. Support technician needs to connect the USB port on a portable monitor to an HDMI port on a laptop to extend the laptop's display. What kind of cable will the technician use to accomplish this? Needs to connect the USB port on a portable monitor to the HDMI port on a laptop to extend the laptop's display. Not this. This is supposed to be easy. Not this, not that. This is an adapter. Cable. Extended IDE cable has 3 color-coded connectors and was the principal mass storage interface. Support technician needs to install an optical disk drive in a new tower. Which panel should be removed so that the technician can gain access to the optical drive and connect the cables? Top panel, side panel, rear panel, bottom panel? Gain access, you gotta do the side panel. This one's moderate. Support technician is installing a new SATA hard drive on a new computer. What is the best type of cable connector the technician will plug in to supply power to the drive? Support technician installing a SATA hard drive. What is the best type of connector? Oh, a SATA. You need a SATA. SATA power. How many pins does a SATA power have? SATA data has 7. SATA power has 15. What's a 4-pin? What's a 4-pinner? Let's go. Let's go. SATA data 7-pin. SATA power. The legacy storage PCs use the Molex. Molex connector is usually white or clear plastic. Okay, the 4-pin is for Molex. Yeah, okay. What's the best type? The 15-pin would be better than the Molex. And USB connector predominantly connects external SATA peripherals, which has a non-standard powered port, eSATA P. Okay, cool, got that one. Continue. This is easy, okay. Computer processing software instructions on the CPU. How does all the computer software appear to a CPU? None of these answers make sense except for binary because the answer is binary. Next. Easy, okay. Support technician working on a motherboard that is 12 inch by 9.6 inches. Has 7 expansion slots. That's ATX, full size. ATX. And then that's micro ATX, and then there's, yeah, full size. Easy. Next. Moderate. Support technician plugged a monitor with a USB-C cable connector into a USB-C port. I forgot to start this, bro. Start now. Might as well. Yeah, because I just hit 130, so I can just do another 130. Okay, cool. Support technician plugged a monitor with a USB-C cable connector. Okay, so monitor with USB-C cable connector into a USB-C port on computer, but the monitor would not function. Why would the monitor not work? USB-C cable connector to USB-C port. It's not HDMI cable. No, it was not DisplayPort. It was not Lightning. It was not a cable with DisplayPort alt mode or Thunderbolt. Yes, that one. This. It didn't even touch on DisplayPort alt mode. I was looking for that. Nice. Difficult. Let's see. Which of the following statements regarding modern connectors and ports is untrue? Modern ports, they use edge contacts. Yes. They use internal connection points. I don't know what that means. They sometimes use keying. Yes. Some are reversible. Yes. They use internal connection points. They use edge contacts. Keying. They use keying. What's the difference? Internal connection points, they use internal. They don't use edge contact. What's an edge contact? I thought keying was edge contacts. It's one of these two then. Or they always use keying? Maybe it's they always use keying. Edge contacts, internal connection points. That's true, it's internal. They use edge contacts, that's false. I have no idea on this one. B. An I/O port is the external connection point for a particular type of bus interface, and the connector is the part of a peripheral cable that inserts into a port with a... Oh, internal connection points means like motherboard connection points versus external, outside the case? Oh, that's what they meant. Wait, regarding modern connectors and ports. The connector is a part of a peripheral cable that inserts into the port with the same... Okay, yeah, so that's for external stuff. I should have gotten that. Wow, that's tough. That's tough. Most connectors and I/O ports use edge contacts that connect the cable wires to the circuits. A lot of cable connectors have ports that have asymmetric design called keying to prevent users from inserting them the wrong way. Ah, okay. Edge contacts and keying is for asymmetrical stuff. And then some are reversible. There's a connector that may be inserted a socket in either orientation. Okay. This is moderate. Okay. Support technician opened a PC case and observed a small computer interface connector plugged into the motherboard. What can the technician know to be true about the connector? It's likely connected to the hard disk. I think so. Each device on a wide SCSI bus must be configured with a unique ID from 0 to 68. Or 0 to 15. 0 to 68, yeah. Wait, these are all true. Only supports one device at a time. Yeah. Transfers one data bit at a time? No. Likely connected to the hard disk? Yeah. 0 to 68. No, it's 0 to 15, I think. One device at a time or connected to the hard disk? Likely supports one device. Oh no, I'm not doing good now. I'm starting to go down. SCI connectors are commonly used to connect hard disks. Yeah. Yeah, from 0 to 15, okay. While serial interface transfers 1 bit at a time, a parallel interface can do 8 bits. One SCSI host bus adapter can control multiple devices. Oh, so it's literally the opposite. I was just flat out, I got the most wrong answer. That's amazing. Wow, that's crazy. Moderate. Manages digital displays, has some older computers with video cards that can support both analog and digital. What type of video interface do these computers have? DVI. DVI can do analog and digital. Let's go moderate, let's see. Support technician is connecting a current standard extended integrated drive electronics EIDE cable. To the mother, and knows that pin 1 on the cable must match up to pin 1 on the port. How can the tech know where pin 1 is on the cable? Oh, bro, come on now. I did not read through this one. EIDE, I don't even know what that is even for. Pin 1 must match up to pin 1. There's a blue stripe, black stripe, red stripe, gray stripe. Black stripe. It has black stripe. It has a red stripe, bro. I gotta read the notes on that one. Video production company. Wait, what is this? Moderate. Okay. Uses removable media to transport multiple files. Has to be prepped on a short notice. Time taken to transfer files from the development workstations has resulted in delays and missed opportunities. To mitigate the issue, company has procured USB 3.2 Gen 2x2 storage devices and Windows PC workstations, expansion cards. Devices and expansion cards support multiple USB hardware port types. Which of the following adapter cables will enable the device to take full advantage of the highest transfer rate? Type A to Type A with USB 3 compatibility, denoted by a blue tab. Type B micro to Type A with USB 3 compatibility. Lightning to Type A, Type C to Type C. The absolute fastest is Type C, I think. Yeah. Type-C connectors support USB 3.2 2x2, 20 gigabits per second. Type A ports with the blue tab supports 10 gigabits per second, 3x2, USB 3.2 2x1. And then Type B micro supports speeds of 10 gigabits per second, USB 3.2 generate 2x1. Okay, so same as USB A. Type A and Type B micro support the same. Lightning connectors mostly used by Apple. Type A to Lightning adapter would not support this transfer rate. Okay, yeah. Okay, good. This one, easy. Support technician opened the case to a PC and saw a square socket component. What component is this? RAM adapter, CPU drive, or CPU? Yeah, that one really was easy. Another easy one, okay. Support technician is installing PCIe card that will use a combination of the system memory and 8 gigabytes of dedicated memory. What type of card is this? PCIe, so it's an expansion card that will use a combination of system memory and dedicated memory. So that's gotta be graphics. Easy. Yeah, that was easy. Difficult. Let's see. Technician needs to install a legacy PCI sound card. Okay. Just gonna highlight that. PCI sound card. Which of the following statements about PCI is not true? PCI Express supersedes PCI. Yes. PCI uses parallel communications. I do not know. The PCI card can fit into the PCIe slot. No. PCI is software compatible with PCIe. Yes. PCI uses parallel. I think so. I think it's this one. It doesn't fit into the slot. Let's go, baby. Let's read these. Motherboards can include PCI ports to support legacy adapter cards, but PCI cards cannot fit into the PCIe slots. PCI uses parallel communications to increase bandwidth. Most of them are 32-bit and work at 33.3 megahertz. PCI is software compatible with PCIe, meaning that PCIe motherboards can include PCI ports. Oh, what I get? 80? Okay. That's not good enough. Dang, so it was those two questions that... Yeah, those ones were tough. I didn't know those. And then this one. This one I didn't know. That's tough. That's tough. Let's read. Where can we read about that? Oh, I was already on the thing here. Hold on, let me do... What's the reader mode? Is it R, Command R? Yeah. Where am I? Here. This one here. Okay. I gotta learn about SCSI. This one I should have gotten right. That was just an L. .68-pin connectors and 80-pin connectors for the SCSI. Control multiple devices. Okay, gotta remember multiple devices for this one. Unique ID from 0 to 15. First and last devices on an SCI bus must be terminated. Okay. Can be enabled internally on the device by setting a switch or physically connecting a terminator pack to a device or the host adapter. So this is for storage, basically, devices. Oh, known to be true. Oh, okay. One at a time? It can be one at a time or 8 bits at a time, right? Parallel interface. Yeah. 1 bit or 1 byte. While serial interface essentially transfers 1 bit, a parallel interface such as... Oh, that's serial. Okay. So no. So the answer is no, it's just 8 bits. Okay. So no. No, this is not 1 through 68, it's 0 through 15. Connected to the hard disk, yes. No, 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 yes. Okay. Okay, I just gotta memorize that. What's the other one I didn't know about? This one, integrated drive electronics. Okay, interface also for storage. Also referred to as PATA. The enhanced bus interface uses 16-bit parallel data transfers. Motherboards may come with one or two host adapters called IDE 1 channel and the IDE 2 channel. May also be labeled as primary and secondary. Single IDE channel is now more typical if the motherboard also supports SATA. Each IDE channel supports two devices, 0 and 1. Oh, red striping, okay, I see. Typically has 3 color-coded connectors. Blue connectors for the motherboard port, black is for the end, and gray is for the middle connectors attached to devices 0 and 1. Pin 1 on the cable must be oriented with pin 1 on the port. It is identified with a red stripe. Connectors are also keyed to prevent them from being inserted the wrong way around. Okay, and this one was B. They use internal. They don't use internal. Connectors and ports are external. Okay. Okay, and this was this one. Okay. Might as well just retake it again right now. Let me see, 80%. How do I... Next, done. Where's done? Review all, back here. Okay. 80%. Yeah, that's not good. That's not good enough. Reset. Alright, now I'm gonna get 100% because I know what I got wrong on that. Moderate, okay, what is this? What are they looking for? Okay, so they want faster things, so USB 3.2 2x2 storage devices. Which cable's gonna work with that? I already know that's just C. Which of the following regarding modern connectors and ports is untrue? That was the one I was just looking at. They do use edge contacts. They don't use internal connection points, they use external connection points. They're sometimes use keying, yes. Some are reversible, yes. Moderate. Installing a new SATA hard drive. What's the best type of cable connector for supplying power? Okay, not USB, that's external SATA, and that's not a standard power. This is old school Molex, so we don't want that. 7-pin is the data, 15-pin is the power. Needs to connect USB port on HDMI port. Oh, this one is just adapter. Easy. So square socket, what is that? CPU. Moderate. Technician is connecting a current standard IDE cable to a PC's motherboard, knows that pin 1 cable was matched with pin 1 on the port. How does the tech know where pin 1 is? Has a red stripe, because I just reviewed that. Manager directs the support technician to plug a device into the comms port. What port is that? That is the serial. Comms is serial port. Open a PC case observed in small computer system. Come on, small computer system interface connector plugged into the motherboard. What can the technician know to be true about the SCSI connector? Likely to be connected to hard disk? Yeah, that's for data stuff. It's not 0 to 68, it's because it's 0 to 15. Does not do 1 bit at a time, that's for serial. Supports one, no, it supports multiple devices at a time, so this one, connected to the hard disk. Easy. Let's see. Motherboard, that is this one that I already know, that's ATX 7. That's ATX as well. ATX. Plugged a monitor with USB-C cable connector into a USB-C port on the computer. Monitor does not function. It was not an HDMI. Well, no. Why would the monitor not work? It was not an HDMI cable. Well, it wasn't an HDMI cable and it wasn't an HDMI port, so that just doesn't even make sense. It was not a DisplayPort cable. No, it wasn't. It was not a Lightning. No, it wasn't. It was not a cable with DP. Yeah, USB-C can use Thunderbolt or DP alt mode. Well, Thunderbolt uses DP alt mode, but it can have DP alt mode without being Thunderbolt, I think. Easy. Let's see. Technicians installing PCIe card that will use system memory and dedicated memory, which is the GDDR, dedicated GDDR. So that's graphics, because these don't use dedicated memory. Difficult. Needs to install a legacy peripheral component interconnect sound card, PCI sound card. Which of the following statements is not true? PCI Express supersedes that. Yes, that's true. PCI uses parallel communications. Yes, that's true. PCI card can't fit into the PCIe slot. Oh, can fit. No, that's not true. Is software compatible? Yes, it is. So that's not. Boom. Needs to install optical disk drive. What panel should be removed? Side panel. It's the biggest one. This is moderate, okay. Digital displays, but has some older computers with video cards that can support both analog and digital monitors. What type of interface do they have? DVI supports both. HDMI is digital. VGA is digital, I think, as well. DVI is both of them. Computers processing software instructions on the CPU. How does the computer software appear to the CPU? Bus, binary, RAM, system clock, binary. Nice, that's what I'm talking about. That's what I'm talking about, baby. PBQs, practice. We got this one already? Oh yeah, we did. Wait, did we? Yeah, we did that one. What about the practice? Oh, we did terrible on the practice though. Before we do that, let's read through it real quick. Let's do a review, skim through it. Where is it? This one, installing system devices. Let's see. Power, wattage. Let's do PSUs. They deliver DC low voltage power to PC components. They convert building AC to DC voltage. Shape, size and shape determines if it can be used, as well as form factors. Most of them are designed based on ATX form factor. PSUs plugged into an electrical outlet using a suitable power cord. Ensure the PSU is compatible with the input voltage from the outlet. North America input voltage is 120 VAC, whereas UK the voltage is 230 VAC, not cross-compatible. Facilities such as data centers typically use Highline because it is way more efficient. Most PSUs are dual voltage and are auto switching. Some have a manual switch, Fixed voltage types can only accept either low line or high line. Okay, obviously. Okay. Wattage rating. Power is the rate at which things generate or use energy, measured in watts, calculated for electrical components as voltage multiplied by current. PSU must be able to meet the combined power requirements of the PC's components. PSU's output compatibility or capability is measured as its wattage rating. So it's typically around 200 to 300 watts. Enterprise is typically over 300. Gaming PCs might require 500 watts. Power requirement for different components vary widely. e.g. CPU can range from 17 watts to over 100 watts depending on the model. If you're building or upgrading systems, simplest way to work out the power requirement is to use an online calculator. Oh, okay. Power output is not the same as the power the PSU draws from the grid power. If a PSU works at around 75% efficiency, a 300 watt supply unit would draw 400 watts from the outlet. Extra energy is lost mostly as heat. Power efficiency is an important criterion to use when selecting a PSU. Energy Star 80 Plus compliant PSU must be 80% efficient at 20 to 100% of load. When specifying a PSU for a system with high power requirements, it's also important to assess the power distribution for its output voltages, 3.3, 5, and 12. Distribution refers to how much power is supplied over each rail. A rail is a wire providing current at a particular voltage. Following table shows examples of how power distribution for a PSU might be configured. Output rail 3.3, max load 20, maximum output 130, plus 5, plus 12, negative 12, plus 5 standby. Note that the output of 3.3 volts and 5 volts has combined limit. Okay. For a modern computer, the output rating of the 12 VDC rail or rails is the most important factor, as plus 12 VDC is the most heavily used. What is negative 12? Doesn't matter. Power supply connectors. The P1 connector. PSU will have a number of Molex and or SATA device power connectors. 20 pin to 24 pin motherboard adapter. A P1 adapter is the primary connector for power from the power supply unit to the motherboard. With that, it uses up to 20 pin. ATX PSU standard has gone through several revisions specifying different connector form factors. Original ATX specification of the P1 connector is 20 pin, but most systems are now on the ATX 12V version 2 specification. Black is ground, yellow is 12, red is 5, orange is 3.3. Okay. 24 pin, 2x12 P1 form factor. Some PSUs uses a 20 plus 4 pin P1 adapter for compatibility with older motherboards. Okay. Entry level power supply, that's the EPS. That I didn't know about, okay. Specification comes in 8 pin, 12 volt connections with 4 pairs of yellow and black wires. And that's only, okay, so I got this one right, based off of just being able to deduce it. Okay, and then this is the, okay. But this is just another one then. 8 pin, 12 volts only. 4 pairs of yellow and black. Molex. Older connector. Okay, we talked about that. It's white color, 4 pins, red, yellow, and black. 5 or 12. The best way is just to memorize the colors and what they mean, and then when you look at them, well, actually, no, that's not the best way, because if there's no picture, then if it just asks you what is Molex, then you have to know that anyway. Okay, so maybe not. I don't know. Gotta memorize it all. KK is... Wait, Molex is the white color one? I thought Molex KK was the white color one. Or Molex just in general is white, okay. Molex KK connector is the smaller one. Has 3 circular pins, black, yellow, red. They look the same. Modular power supplies. Modular PSU has power connectors that are detachable from the unit. Oh, okay. Modular PSU, okay. Non-modular might have 4 or 5 Molex or SATA device power connectors, but the PC might only require 2 of them. So with the modular one, you can remove those. Redundant power supply. Maybe fitted with 2 PSUs. One is a redundant one. Could also be connected to a different grid power circuit. Requires a compatible motherboard. More commonly found on server systems than desktops. On a server, each PSU plugs into a back plane and is hot swappable, which means that you can switch it out without turning everything off. Okay. Fan cooling. Components in a computer system emit heat because of some degree of resistance when electrical current passes through them. Without a cooling solution, okay, so you need a cooling. Okay, so particularly affects CPUs. CPUs require cooling. Heat sinks as well as CPU. Memory modules and graphics adapters also require cooling solutions. Heat sinks and thermal paste. Heat sink is a block of copper or aluminum with fins. I'm gonna get into some PC building after I take this class. I never had a PC or was into that, but I'm gonna start getting into different kinds of builds now that I know how all this stuff works. Let's see, heatsink, block of copper, all aluminum with fins. Fins are exposed by larger surface area. Okay, I know what that is. Heatsink is affixed to the surface using thermal paste or a thermal pad. So CPU, or CPU socket, CPU, heatsink, and CPU fan in one. Retaining clip or push pins, passive cooling, fan. Okay, there's not much in here really that's important. Fan cooling? No, liquid cooling. Using pumping water around the chassis. Water is more effective coolant than air. A good pump can run more quietly than numerous fans. Ooh, liquid coolant is the way to go for show. Open loop liquid-based cooling system. Uses the following components. The water loop / tubing and a pump to push the coolant added via the reservoir around the system. Water blocks and brackets are attached to each device to remove heat by convection. Attached in a similar way to a heatsink fan assembly, then connected to the water loop. Radiators and fans are positioned at air vents to dispense the excess heat. Open loop system usually needs draining and cleaning and refilling periodically. Important to keep the fan and radiators dust free. Drain it before moving the PC. There are also simpler closed loop systems that install to a single component. Yeah, maybe closed loop is better, I don't know. Storage devices, mass storage devices. Referred to as mass storage, or if it's internal, it's called a fixed disk. Can be 5.25 width, 3.5, 2.5. This is standard, that's extra big. Several drive bays to fit the form factors. Oh, okay, this one is for like, not hard drives. This is for standard hard drives. This is for like other stuff, DVG drives or other things that might be in there. You can use a caddy to put it in there. Okay, common factors for choosing mass storage: reliability, performance, and use. Concerns the risk of total device failure and the risk of partial device corruption or partial data corruption. Performance by the type of data transfer the device will use predominantly. Read and write performances have different characteristics. There are also differences between sequential access, reading data from the same block, as might happen when transferring a large file, and random access, reading data from different locations on the drive or transferring lots of small files. Data throughput, megabytes or gigabytes per second. Number of input-output operations per second, IOPS, can be achieved by a device of different kinds of data transfer operations. Use, okay, whatever. Solid state drives. SSD uses flash memory for persistent mass storage. Lower risk of failure, susceptible to degradation. Uses wear leveling routines. Wait, I should probably wear leveling. Kind of a good vocab word there. Can be installed as the computer's only drive or as a boot drive with an additional hard drive in second scenario. Okay, yeah. SSD might be a 2.5-inch caddy installed to a SATA port using a normal SATA data and power connectors. Okay, mSATA form factor. Okay, so SSD is the one that might use a SATA thing, and mSATA form factor allows the SSD packaged as an adapter card to be plugged into a combined data and power port on the motherboard, like M.2 slot, right? With both, the main drawback is that the 600 megabytes per second SATA interface can be a bottleneck to the best performing SSDs. Modern SSDs often use PCIe bus directly. Oh, okay. SATA uses advanced host controller interface. These guys gotta be highlighted, bro. Oh wait, I gotta do enter edit mode. PCIe-based SSDs use non-volatile memory host controller interface specification. Maybe I don't need to do all that, actually. PCIe-based SSDs are called NVM Express. Non-volatile memory host controller interface specification, or N-Express. NVMe SSD can either be packaged for installation to a PCI slot or as an expansion card or M2 slot. Considerably smaller than a PCI adapter, oriented horizontally rather than vertically. Power over the bus, so no separate cable. Different widths and lengths, and also secured with a screw. Okay. The NOT and NAND flash memory used in SSDs comes in different types. Single level is more reliable and more expensive than multi-level types. NAND flash memory. SATA. As an adapter card. So does that mean PCIe SSD? Or does that also count as an SATA and NVMe SSD? M2 is a physical form factor. You can obtain M.2 SSDs that use SATA or HCSI bus. These typically will not perform as well as the NVMe based M.2 SSDs. Okay, so you can get, okay, I see. M.2 socket may be able to support both types of drive or only one. Check the documentation. SATA interface SSDs are usually B keyed. 2-lane PCI SSDs are usually BM keyed. And 4-lane SSDs are usually M keyed. I don't get it. B keyed? BM keyed? I don't know, I can't tell. SSDs are vulnerable to ESD. Okay. Hard disks. Stores data on metal or glass platters. Coated with magnetic substance. Each platter is accessed by its own read/write head, moved by an actuator mechanism. Platters are mounted on a spindle and spun at high speed. Low-level formatting is also referred to as drive geometry. The performance of H hard disk drives, determined by the speed at which the disks spin, measured in RPMs. High is 15,000 to 10,000, average is 72,000 or 54,000 or 5,400. RPM is one factor determining access time. Access time is the delay as the read-write heads locates a particular track position. Seek time is the time it takes to move from one point to the point in which the data resides. Measured in milliseconds. Encompasses the total time for your computer to read-write data. High-performance drive will have access time below 3 milliseconds. Typical drive might have an access time of around 6 milliseconds. Internal transfer rate, how fast read-write operations are performed. Most HDDs use SATA interface. Legacies use EIDE or SCSI. Two main form factors, 3.5-inch units or 2.5-inch laptop units. Varying in height, 15 millimeters, 9.5 millimeters, 7 millimeters, and 5 millimeters. Okay. RAID. Oh, that's what I don't remember any of the RAID stuff actually. So you can have RAIDs. Redundancy sacrifices some disk capacity but provides fault tolerance. RAID appears as a single storage resource or volume. Can be formatted. Represents a drive configuration given a type of fault tolerance. Or a RAID level. Oh wait, that's what I should have. I should do RAID level. RAID level represents a drive configuration. Maybe something like that. Given a type of tolerance. Basic RAID levels are from 0 to 6. Also nested RAID solutions, such as RAID 10. RAID uses a dedicated controller instead of it's installed as an adapter card. RAID disks are connected to SATA ports. on the RAID controller adapter card rather than to the motherboard. Entry-level controllers might only support RAID 0 or 1, mid-level, RAID 5 or 10. RAID levels. Okay, now we're getting into it. Disks should be identical in terms of capacity and type and performance. If they're different sizes, the size of the smallest disk in the array determines the maximum amount. Yes, you want them all to be the same. Okay. RAID 0, striping without parity. Disk striping divides data into blocks and spreads the blocks into fixed order among all the disks in the array. Divides it into blocks and spreads the blocks in a fixed order. 1, 2, 3, 4, 5, 6. Okay, so stripes it across 2 different things. This improves performance as multiple disks are available to service requests in parallel. RAID 0 requires at least 2 disks. Provides no redundancy at all. If any one disk fails, the whole volume will fail. RAID 1 mirroring is a mirror drive configuration using 2 disks. So it's just mirrored. Because disk space is utilization is only 50%. RAID 5 and 10. RAID 5 striping with distributed parity. It's like RAID 0 but with distributed parity. 1, 2, 3, 4, 5, 6. And this is parity for 5, 6. Parity for 3, 4. Okay, okay, so that's a whatever complicated mess with that, but that makes sense. Okay, so the parity, so the backup is distributed across all of them. So it's striped across 3 or however many you have, and then parity is automatic, is configured in a way, okay, across all 3, distributed. Level of fault tolerance and available disk space is inverse. As you add disks to the set, the fault tolerance decreases, but usable disk space increases. Configure a RAID 5 set using 3 disks. A third of each disk is set aside for parity. RAID 10 stripe of mirrors. Nested array configuration combines features of 2 basic RAID levels. RAID 10 is a logical striped volume. RAID 0 configured with 2 mirrored arrays. RAID 1. Oh, okay, that makes sense. 1 and 0 is 10. So data is striped and then mirrored. No. Here. 1, 2, 3, 4, 5, 6, and then mirrored again. This way. Excellent fault tolerance. 1 disk in each mirror can fail, and the volume will still be accessible. Oh yeah, because they're striped across the 2 things, not this way. Striped here. Carries the same 50% disk overhead as mirroring. Even number of disks. Must require at least 4 disks. Yeah, 1, 2, 3, 4. The 2 striping, and then backups. Or the mirrors. Okay. So RAID 0, striping. RAID 1, mirroring. RAID 5, striping with distribution. RAID 10, striping with mirroring. Okay. Okay, let's see. Gonna have to put a pause on this guy actually, because I'm gonna go eat some lunch real quick so I can keep going hard later. Let's see, 2 hours, okay. I'm gonna put this in the description. I don't know how to open that, never mind. Alright, I'm gonna go on a food break real quick. Okay, change of plans. I'm gonna end the stream and continue doing more studying off stream because I'm gonna go visit some family real quick and do more studying there. Finish up some more PBQs and quizzes there. So that's the plan. Maybe I'll continue back when I come back tonight, maybe around 8-9 p.m. So yeah. Okay, bye.